Okay, so we were at the isolated memory sampler that has a rotation transform applied to it. Scrolling down. Okay, so here's where we're getting into the actual main shader, because this is main. If we don't have any memory set up yet, we use the bare bones default shader that just shows us the colors that were set up on our quad. So bare bones. Like you usually will never see this unless you pause before the first game loop iteration, or you invoke some type of error that crashes part of your code, but not the code that comes. Let me think. If you crash part of your code, sometimes you will see this. Usually you will not see this unless you put a debugger breakpoint before the first draw call. Depending on how your code crashes, sometimes the first GL draw arrays will get called successfully, and you will see this. So seeing this is, if you're not expecting this, it's a bad thing. Okay, so if you do have memory, then we're going to go into the section of code down here, and everything is indented really weird, but it's just to save me space, because that was kind of my design choice. Is sometimes I do make the indentation a little bit wonky just to save space, but yeah, I don't know what to tell you. Okay, so the render mode, if render mode is 0, which is the way it's going to start out, we use a default shader. And if the render mode is non-zero, then we delegate the shading logic to whatever editor mode is active. So basically, I want this code to be very editor-centric. And because of that, I was debating or contemplating if I wanted like different render modes, like render mode 0, render mode 1, render mode 2, and just have all these different render mode features. And I'm like, nope, do not do that. That's just going to complicate things way too much. Because the goal here is to have a very editor-centric project where every editor gets its own unique shader. So I'm like, nope. We're gonna kind of go with the same similar pattern here of if there's no memory, use a default shader, and if no render mode has been set, then use this default shader for the render mode. And if a render mode has been set, well, that just means that we delegate to the editor mode. So that's kind of weird, I guess. But yeah, I think originally I wanted the render mode to have like different types of overrides. But for right now, like if render mode is 0, I basically want it to be like a memory inspector, and I might have some other logic in here in render mode 0 eventually, where if it's render mode 0 and editor 1, we have a memory inspector shader for editor number 1, and then if it's render mode 0 and editor mode 2, then this logic would be a memory inspector for editor 2, etc. Right? So basically, render mode 0 is either a default shader or a memory inspector. Right now, it's not a memory inspector at all. I think it's just some weird pattern. Actually, no, the pattern is based on what's on that buffer, because it's just doing the texel fetch from isolated memory. So right now, this acts as a memory inspector for the isolated memory, no matter what the editor mode is. Okay, let's see. Okay, only 5 minutes in. Okay, so if the render mode is greater than 0, then we delegate to these different editor modes and use shader code that is specific to a different editor. And so this should not look unfamiliar. We have we inject into this big string we're building different shader code, right? So this will fetch some shader code that's associated with editor mode 0. This fetches shader code associated with editor mode 1, and so on. Now, the idea of doing this was just trying to break apart. So these big strings like this are very, very unwieldy. So I would really like to, eventually get the shader code to a point where it's done and then never have to ever touch it again, because it is a pain. Because look how ugly like this is right here. It is a pain to edit. Like, even with these multi-line strings, it is a pain to edit. So the idea is eventually to be able to get this segment of the shader code down and finalized and completely finished, and then all of the changes that need to be done will be done in these, sub functions, and then, ad infinitum, right? Because then we can do the same pattern for whatever shader string is in these functions as well. Okay, scrolling down. Okay, not much changed here. I've got 2 breakpoints here. So the canvas width and height when we are booting up is going to use the global configuration dot initial viewport canvas width and initial viewport canvas height. So nothing fancy. I just had that note to factor out the 512s here and unhardcode them, and I finally got around to that because now I have that data all wired up with the GPU-CPU synchronization. Let's keep on scrolling down. So this is just our OpenGL setup code to get the quad that we draw on. And so there's nothing really fancy here. We've kind of already gone over all of this ridiculousness. Yeah, just okay, right? And then we got our quad configuration here. What else is here? We've already been all over this. I'm just looking at it. Has this changed? Okay, something here changed. I know that okay, so canvas size. Okay, so this comment looks like it might belong to some type of error checking that I moved. Yeah, so I'm gonna guess that is this right here, this check right here. This was originally written for troubleshooting. It didn't solve the problem. The problem was yeah, I don't know. I mean, I guess we can just rip this out and you know what, I'm just gonna, we might as well make this shorter, so I'm just gonna say C canvas size troubleshooting. I'm gonna make a little footnote there, and I'm gonna put like hashtags there. And I'm gonna go all the way down to my comments section where I have a whole bunch of stuff. And I'm gonna put a little hashtag here, hashtag canvas size troubleshooting. And then I'll just make a little section here. Like that. And put the other hashtag there. Okay, and let's now I got it down here in the comments section at the bottom of the file, and let's go back up to the top. Okay, and now we're over here. So kind of like burying comments that are more of a distraction than a help. Right? Because we're already very verbose. We don't want to get distracted by that. Okay, so right here, the GL viewport. This was originally hard-coded, and now we're using the global configuration dot initial viewport canvas width and global configuration dot initial viewport canvas height. And then note that these values are also the same as this. Actually, there's no WID and HIG, right? Because it's this, but since it was, I took the luxury or the liberty. I took the liberty to abbreviate here because these are just comment footnotes. Okay, so this is our first GL draw arrays call, where you'll see that kind of like rainbow quad color. Let's keep on going. Boy, there's a lot here. So I see something commented out. What is this? Debug flood fill. Why are you commented out? Okay, so I believe this is commented out because I may want to put it back in later. Definitely, because we have the checker. We have debug fill pattern checker outline, and that probably uses the same coordinates, yeah? Yeah, this uses the same coordinates. So because... Yeah, this doesn't even tell me what color. Huh, alright, well, I'm not going to worry about... It's a debug fill pattern. Exactly what that debug fill pattern looks like, or why it's called flood fill, I don't remember. It doesn't matter. Checker outline. It's not even a checker outline. It's just a gray outline. You know what? We could rename it to gray outline. Because I feel no need to do a checker outline. Yeah, I don't care right now. But should I? Yeah, don't care. I'm being lazy, but yeah, I really should rename it to a proper description so that when you see a gray outline around something, you can say, oh, it probably came from this gray outline function, but you don't see any gray outline, you only see a checker outline, and that might be a little bit confusing. God. Okay, now I'm just... Okay, now I have to. Let's do it. So checker outline, checker outline, and... right, so we're just using the... RGBA right here. Where is that? Okay, 128, so that's gray. Yeah, I mean, most of it, right? We could copy paste this logic eventually if we want to actually create some type of checker outline code. But right now, what we're going to do is we're going to just take checker outline and we're going to search for every occurrence of that and just replace it with gray outline. Oh boy, I don't spell... Okay, only problem with gray is G-R-E-Y or G-R-A-Y. I don't know. We could change the color and then not have to worry how to spell it. Checker outline, or I could just call it solid outline and, you know, color be damned. You know what? I'm just gonna get really terse. So sometimes I get terse because I don't know how to... No, because I mean, even if we use the first 3 letters, it's still going to be GRE or GRA. We could call it desaturated monochrome. That's a mouthful. I don't know. I'm just gonna call it 1 pixel solid yeah, that's ugly too. 1 pixel solid outline. Fine next, okay. Let's just do this. Okay, now let's look at all the replacement points. Let's make sure we haven't messed anything up. 1 pixel solid outline, 1 pixel solid outline, 1 pixel solid outline. Okay, yeah, I think that's good. Okay, yeah, we'll just call it 1 pixel solid outline. That's good enough for me. Let's just make sure we haven't broken anything. So we'll go back over here. We're going to refresh, activate the correct shader, and that looks good. That's right. Okay. Okay, keep on scrolling. Okay, our bootstrapping uniforms. Nothing has changed here, right? You have the has memory, render mode, editor mode, game time, and the hot swapping index, right? And those are kind of grandfathered in, and we're not going to do anything fancy with them. Even though now that we have, moved to encoding things in a texture, technically we could move those into the texture as well. But I don't know, just doesn't seem like a good idea. Also, anything that, like, this is going to be sampled every frame of the shader no matter what. This is also going to be sampled every frame of the shader no matter what. Same with this, and then the game time needs to be updated every single frame, so we probably should use a normal uniform just to have it as optimized as possible. This, I really don't have a good justification. Actually, a good justification is this is going to mess with how we're mapping texture memory, and so if this variable is actually stored on the texture memory, but it dictates how texture memory is allocated and where it's stored and all that stuff, the uniform would have the ability to nuke itself. So that would be bad. So we're not gonna store it in the texture. We're gonna store it as a normal uniform. Oh boy. Okay, 19 minutes. Okay, so we got our adapter graphics.gpu variable controller. Still not sold on this. Like, it's there, so we're not going to change it. But really, all the GPU variable container is it's a namespace for functions that are used to manipulate our uniform containers, and so that's overly convoluted. This is OOP overkill. Really, we should have used a procedural approach where we just namespaced out the functions. I mean, it gives some useful categorization, but nothing that couldn't be done with a namespace or something. Right, with the need to instantiate this, it just there why? But now it's a singleton, and we're using a class just as a namespace, so we're making like two mortal sins of programming as far as I'm concerned. But we've already done it. We're gonna move on because if we tried to fix every single little stupid thing we did, we would never get anywhere. Okay, adapter graphics. Right, so our GL context, we're going to name it context graphics. All program, it contains the vertex program and the fragment program, right? Our vertex shader code and our fragment shader code. But as a program, right? So not the strings, this is the actual compiled programs. And then our canvas HTML, literally canvas HTML. Now, if this were written in C and, using native Windows, right, we would not have this variable at all, right? It just wouldn't make sense. So that might be a possible point of headaches if I start refactoring this into C code. Okay, scrolling. Does this still depend on adapter graphics.context graphics? So that's interesting. I can't see the right. So when I highlight context graphics, it's not referenced anywhere in this code, but the note says that there is this dependency. So it's probably good that I wrote the note because it's definitely not obvious when I look at it. So what does that mean? Below depends on adapter graphics.context graphics. Adapter graphics has memory. Yeah, I'm not sure if that's quite true. Like, yes, this code definitely depends on adapter graphics, but specifically context graphics. Because it's the GL code, and okay, yeah, because the context graphics is basically all our WebGL functions, and then the GPU variable container that manages the synchronization between the GPU and the CPU, right? And so the U32 put is going to persist is going to set our uniform values on the GPU, or on the GPU side, like on OpenGL side. So yeah, so this call definitely is using adapter, the right here, adapter graphics.context graphics. It definitely is. All right, it took me some time to think about it, but that's good. Why I have that? This comment is definitely good because because that's not immediately obvious. Okay, let's keep going. Because that hasn't changed. I'm just making sure things are correct. Giving them a once over. Okay. Fill patterns. Okay, we got to keep scrolling because there is a lot here. Okay, text image 2D. That hasn't changed. I'm just okay. Pixget texture sampler uniform. What is this part of? This is okay. Well, it has an underscore, so it's a private function of what? What is this thing we're in? Pixput. Pixel get. Some type of GPU CPU synchronizing thing here. Okay, GPU variable container. Yeah. Okay. So we can kind of wait till we get out of this scope. Okay, uniform helpers. Loop table tick has not changed. Loop table tick, native window code. In the documentation, it says that key press is obsolete. So we're not going to support that. We're just going to use key press is, right, the keyboard equivalent of like a mouse click. So it's nice. Though but then how does key press differ from, or maybe it's not. Maybe that's just the first event after key down. Oh, maybe that's why it's obsolete, because it was interpreted differently. Because key press could mean the first key down event, or maybe key press means the last key up event. Or not, no. It could either mean the first key down event, or it could mean the key up event, depending on how you want to interpret what key press means. Or maybe key press is supposed to be paired with key release, but we already have key up. So I could see there are a lot of ambiguity with the key press. So okay, but I mean, you could probably say that with click, right? Because isn't click just a mouse up? Well, you have mouse down, out, over. Okay, so click is a mouse up. So the proper symmetry is here. All right, we got up, down, out, over. What about in? Whatever. Okay, anyways. Let's keep going. What are we? 26 minutes. So keyboard handling stuff. It's not the best keyboard handler, but it'll be enough to get an editor working. It will not be suitable for actual gameplay mechanics. So, okay, pull events, loop table tick, game objects. Okay, so this namespaced functions, we've added some things in here. Right now, I have a little list of different functions: move left, move right, move up, move down, zoom in, zoom out, pull left, pull right, pull top, pull bottom, push left, push right, push top, and push bottom. And so these are all different modifications to the rectangle inclusive. So this is procedural code, but written in an object-oriented kind of format. So I use this tag PROCOOP for procedural object-oriented programming. So this would be, if you wanted to read this properly, it would be rectangle inclusive dot move left. Right, so these right here, this column right here, you can interpret them as member functions. And when the convention, as far as I'm aware, for object-oriented code, when using something that does not natively support it, so like a hybrid procedural object-oriented style, is that this argument is the first argument of the function. So I'm making sure to say that this is a member function of rectangle inclusive, and so this argument is rectangular inclusive, and that is why it's the first parameter, and then this is the actual argument to the member function move left. And the same pattern is repeated, so I'm not going to explain this again for all the subsequent functions. Move left is just going to take the entire rectangle and move it to the left, and we'll do that by subtracting the same amount from both x coordinates. So you could think of these x coordinates as the x boundaries, right? It's going to move the left edge over to the left, and it's going to move the right edge over to the left, right? So both of our vertical edges are just getting moved over to the left, and that's how you translate the rectangle to the left. Move right, just the same thing in reverse. We take the left and right edges, and we just move them to the right by plus equaling them with the inputted value. Okay, so move up is same kind of logic, except now we're using the y-axis. So the top and bottom edges, we're going to minus equals, right? Because in graphics, the top left origin is 0, 0. So that means the top edge is the y0 coordinate, and the bottom edge is the y1 coordinate. So we're moving up screen when we do the minus equals. That can be confusing if you haven't done graphics before. It's still confusing to me. And then OpenGL doesn't do the top left origin for its shader code, but I'm going to stick to top left origin for everything, and anything that inverts it, I'm just going to add corrections so that I can always think of the origin as being in the top left no matter what I'm working in. Okay, so moving down, so moving the rectangle down, right, we're going to manipulate the top and bottom edges, and this time we'll add the same amount to both the top and bottom edges to move down the screen. Yeah. So zooming is achieved by pulling in every single edge of the rectangle. And so we're going to take the left edge and we're going to add to it because that's going to move towards the center of mass of the rectangle. The right edge we're going to minus because that's going to move towards the center of the mass. This is the top edge, and we're plussing, right, because plus goes down screen towards the center of mass of the rectangle. And then the bottom edge we're going to minus, which is going to move up screen towards the center of mass of the triangle. Now, one thing we got to watch out for is as you keep on zooming, eventually these coordinates could cross over each other, and then you would get an out of order rectangle where the x1 coordinate is less than the x0 coordinate, right? You get a malformed rectangle, and that would be bad news, so we need to watch out for that. That's right. So there's a little note here, do not invert on yourself. And basically what we're going to do right here in the code is if we detect that there is an inversion, we're going to make the points coincidental. So let's see, right now the x is being minused. Do we have enough code here? Are we... okay, yeah, because we have to look for x crossover and y crossover. So 2 blocks of code is correct. So if x1 ends up less than x0, what we're going to do is, remember that we moved both of these at the same time. So we're not going to exactly snap one to the other to fix what just happened, but the best solution, or the easiest solution I thought of was, okay, we'll just average the coordinates and then set them to be the same, or coincidental. So we're going to average x0 and x1 by adding them and dividing them by 2. Then these rectangles are supposed to be unsigned integer coordinates, and these coordinates are also supposed to be whole numbers. So we're going to math.floor this as well after averaging them, just to make sure that we haven't turned these into float coordinates. And then after that, right, x0 and x1 will now be coincidental. And so this is effectively zoomed in on 1 pixel. That's as far as we're going to zoom. And 1 pixel will eventually be 1 tile. And so the furthest you can zoom is 1 tile filling the entire screen. And that is plenty of zoom as far as I'm concerned. We don't really need any more zoom than that. Let's see, same thing for the y. So if y1 is less than y0, we're going to take y0, y1, average them, and then set that average value to y0 and y1 so that the points are now coincidental. One more check. I'm not sure if I want to have some of this bounds check in these functions, but if any of these values go negative, we just want to make sure to keep it positive, because one of the rules of my rectangles is that they don't go negative. These are unsigned values. but I might take out this checking code and make another series of functions with the exact same name, but have the postfix bounded and supply a third argument somewhere that is the bounds of where the viewport is allowed to be. Because right now it's kind of inconsistent code where some of these functions have bounds checks and some of them don't, right? Like there's no bounds error checking here or correction in these functions, so why should it be in other functions, right? There's just a big inconsistency here, and I'm not a fan of it, because if some of your functions are correcting the format of the rectangle and other functions do not correct the format of the rectangle, then there'll be inconsistencies with what goes wrong in your code, and that can make problems a little bit harder to detect. Like, oh, nothing goes wrong when I zoom in and out because we have checks here, but then something goes wrong when we're, moving the viewport right and left because there's no checks there or something, and is that actually the case? Yes. Right now, we could move the viewport out of bounds by moving it, but if we do zooming out, the viewport won't go out of bounds. But it will probably distort in weird ways once it starts to hit the edge and other edges. I just don't. Yeah, this is ugly. Okay, so pull left. So the pull functions are the inverse of the push functions. They pull the rectangle in on itself. So pull left is going to take the left edge of the rectangle and pull it in on itself. Pull right takes the right edge of the rectangle, pulls it in on itself. Pull top and pull bottom, same thing. So it's as if you were inside the rectangle and you were pulling on the walls of the rectangle, right? Same thing with the push functions. It's as if you were in the center of the rectangle and you were pushing on the different walls of the rectangle. I got some little diagrams because I tend to mix up my right and left. So kind of diagramming how things need to change. Okay, so pulling left, what are we going to do? First, we got to locate where is the left side. That's going to be the x0. And which direction does it have to go? Well, if we got to pull it in, we got to add. So that is correct. We also want to make sure that as we're pulling it in, we don't want to invert on ourselves. Like I said, I don't know if I want this error checking code in here. I think I want to put it in a different a function of a similar name that states that it has some type of correction code in it, because that's okay. So pull right. You got to locate the right side of the rectangle, so that's going to be x1, and we're going to subtract the value to pull it in on itself. And once again, we're going to check to make sure nothing crosses over. And oh god, I'm at 38.